right. Wow. It's quite a lot of people. Uh, so, let's start. Right, so my name is Thierry. I'm from Belgium, the land of chocolate, waffles, and beer, and very expensive political systems. Uh, I spent most of my time as an engineering lead at the fintech startup Pax Familia. And on the side, with Thinking Labs, I help organizations adopt continuous integration and continuous delivery. And the topic today is, well, kind of related to that. This year, I've also organized the European edition of KitCon, which is the Continuous Integration and Testing Open Space Conference in Ghent, my hometown in Belgium. Right, so let's start. This is not very interesting. What is coming is more interesting, and we don't have that much time. So let's start. So first of all, I want to introduce two teams, two quite different teams I've worked with in the past. Somewhere in 2012, I had the opportunity to do some technical coaching with the purpose to upscale the engineering skills of a quite novice team, although they had a working experience ranging from 5 till 20 years. And fortunately, I didn't do that alone. We were the two of us, which is quite comforting, especially if you have to introduce lots of change in front of people with lots of working experience. And when we arrived, we discovered a situation that we weren't quite expecting to still discover in 2012. So no one, except for one person, was using any version control system. Yeah, right. Source code was shared using shared drives, if source code was shared. So first thing we did was actually introduce a version control system, and because the team was quite novice and didn't have experience using version control systems, I thought like, well, Git would probably be a bridge too far, too many concepts to learn. And so I suggested, well, let's go for Subversion. It's quite easy, it's only three concepts. You just check out code, you modify it, you check it in again. Fairly simple. Now, at the time, it was also said that branching was rather painful in Subversion, although more easy than in CVS, but still more difficult than in Git. And to be fair, at the time, I didn't understood much about branching strategies. It seemed all very complicated to me, so I suggested that, well, the whole team was going to commit directly into trunk. And that worked pretty well, because there was a second thing we introduced right from the start, and that was continuous integration with team commitment that any change had to be covered by an automated test, and preferably unit tests. Now, at the time, I absolutely didn't know that this was a valid branching strategy, and it took me years to discover that this way of working actually had a name and that it was called trunk-based development. Then when the team gained more confidence and gained more maturity, well, we thought it's time to migrate to Git, with the main reason for that there is just more tooling available to manage Git repos, and because we wanted to introduce the pull request model as a code review. And so we wanted to be able to create branches more easily. Now, what works for the open source world, where you have a core team that is managing a software system and accepts changes from the outside, doesn't necessarily work in an enterprise environment where you have a co-located team and where trust is very important. And so, like many powerful tools, there are many ways to use them, and all of them are not right. And here Jazz is referring to the use of feature branching and the fact that proponents of feature branching, that proponents of distributed version control systems use feature branching to sell distributed version control systems. And together with all the vendor tooling that exists around distributed version control systems, it makes everyone blind for the problems that arise from the use of feature branching. And with that team, we actually hit those problems really hard. And we tried to find solutions by introducing ever more complex technology and ever more complex processes, but it never really solved the problem. And so we sat together and we just decided to let go on those feature branches, and we went back to what worked for us, and that was string-based development, and we never looked back. After that mission, years later, I had the opportunity to start a new mission in a totally different organization, quite agile, working with highly skilled engineers. Everyone was almost working all the time in pair, but they decided to use Git flow as a branching strategy. And when I arrived, branches were living for somewhere between 5 days until 30 days, with team members having to rebase all the time, fixing merge conflicts, losing quite some valuable time. And so when I saw that, and with the experience I had working with this one team, I suggested, well, might we not try string-based development? And at the time, a new project was going to start where only 2 team members were going to work on. And so I thought, well, this wouldn't be very riskful, is it? Well, trying to convince people of the benefits of string-based development is really not an overnight task. Every time I suggest that, especially in front of skilled engineers, I always get that same reaction. They stare at me like I'm stupid. Are you insane? Are you just suggesting everyone in the team is going to commit directly into mainline? It's going to be a mess. So, although string-based development is implied by continuous integration, although it has been reported by the State of DevOps report since 2015 that string-based development is a significant predictor of high software delivery performance, and although organizations like Microsoft and Facebook and Netflix and Google at very, very large scale are doing string-based development, it is still one of the most controversial practices in the IT industry. And so I failed. I failed in getting that organization just do an experiment. And well, the reason for that was that I was lacking the right arguments. I only had this one experience with this one team. Although in my past career, I worked many times with some sort of branching strategy. I never really paid attention to what happens and what problems arise. And so I took this opportunity to just observe what happens. And this resulted in this presentation. So before we move on, I want to introduce some definitions. You probably know the concepts. It's just to make sure we are all aligned on the meaning of them. And so the first one is, what is mainline? So mainline is your line of development that acts as your reference from where builds are created and that are fed into your deployment pipeline. So for Git, this is master. For Mercurial, this is a default branch. And for Subversion and CVS, this is string. Feature branching. Well, feature branching is the practice where people do not merge their work into mainline until the feature they are working on is done, but not yet done. Done means it is dev complete, but there is still a lot of work to be done until that feature gets deployed into production. You have to create a new build, you have to run all your automated tests, you have to perform your manual exploratory testing. Eventually, you have to run security and performance tests. Then you can deploy into production. Then you have to run your smoke tests, and then you can release to your end users. Quite a lot of work to be done yet. So when we speak about feature branching, we really speak about long-running branches, meaning they live longer than a day. What is continuous integration? Well, it's a practice where everyone in the team integrates their work at least once a day, leading to multiple integrations per team per day. And every integration is validated by an automated build. So it's a practice that ensures always working software on mainline, and it gives you feedback within minutes. And this requires that everyone in the team commits at least once a day into mainline, that every commit triggers an automated build and execution of all your automated tests, and that whenever the build fails, it gets fixed within 10 minutes. And the easiest way to fix a broken build is just to revert the last failing change and going back to the last known good state. So continuous integration is really a practice. You don't need much tooling for this. The only tooling that you need is a version control system and an automated build. James Shaw wrote a very funny article about this, and it's called Continuous Integration on $1 a Day. And it's quite old. It's somewhere from early 2000. And lastly, what is the goal of your organization? Well, it's to sustainably reduce the lead time to create positive business impact. And your lead time is your clockable time between, well, we have an idea, this idea gets implemented and gets deployed and released to the end users. And positive business impact is anything that generates money for your organization, this is your turnover, saves money for your organization, these are your cost savings, and protects money for your organization. This is being ahead of your competition. Now, we want to reduce this lead time to accelerate feedback. We want to know as fast as possible if the thing you just implemented is actually being used by your users and how it is being used by your users. And based on this feedback, well, you can take new decisions and you can run new experiments in production to find new ways to delight your customers, which is a huge competitive advantage. Now, before I could ever suggest string-based development again, I had to understand why teams are using feature branches. What problems are they trying to solve with it? And so I've asked proponents of feature branching for their reasons. And I got several, and I wanted to share 4 of them. And the first one was, well, it allows us to work in isolation, and therefore we are more productive. And that sounds very fair and very obvious. But it also looks like it's a local optimization. We are, in fact, optimizing for individual developer productivity. But developing IT systems is rarely an individual activity. It's a team activity. And so your team will only go as slow as your slowest merge. As long as you haven't merged back into mainline, you simply do not know how much work is left to do, due to merge conflicts and due to potential rework. And so it makes integrating changes into mainline very time-consuming and very unpredictable. And so it makes your whole software delivery process very unpredictable, which will impact your lead time in a negative way. And remember, the goal of your organization is to actually reduce this lead time to create positive business impact. And here we are doing the opposite. So instead of optimizing for individual developer productivity, you should optimize for team productivity and choose a team-oriented branching strategy. Second reason I got was, well, if we have a refactoring that is going nowhere, well, we can just delete it. And again, this sounds fair. But what I think they are trying to say is, well, look, we have this problem, we don't know the solution right away, so we are just trying something by committing code in a remote branch. And if it doesn't bring us to a solution, well, we can just remove that code very easily. Now, if you don't know the solution to a problem right away, why not trying a spike? And this is the whole purpose of a spike. It's to write throwaway code to test an idea. And the output of a spike is really not production code. The output of a spike is knowledge creation. And so after a couple of hours, you should know if a spike actually worked, if the idea worked. If it didn't work, well, no problem. Just throw away your code and try another idea. If it did work out, well, fantastic. You found the solution to your problem. Again, throw away your code and start over again. But this time, use the knowledge you have just created to implement the solution in small incremental steps. The third reason I got was, well, it allows us to control the quality of what goes into production because, well, only the features on feature branches that went through a gating process called a code review get merged into mainline and as such get deployed into production. Now, controlling quality, isn't that the purpose of continuous integration and by extension continuous delivery? So the whole objective of continuous delivery is to eliminate bad release candidates as soon as possible. Only changes that went successfully through all stages of your deployment pipeline and that have been thoroughly tested get deployed into production. So in my humble opinion, this is the only effective way to control quality of what goes into production. And lastly, it allows us to control which features get into production and which not. Well, because only the features that have been merged into mainline will get deployed into production. Now, what they really try to do is preventing that unfinished functionality get into production. Now, what we are doing here, in fact, is using our version control system to turn features on and off through manual merging, which is nothing else than a poor man's modular architecture. So instead of using our version control system as a toggling mechanism, well, we should design our systems to be able to turn features easily on and off at runtime and at deploy time. So why are feature branches a problem? Well, first of all, it delays feedback. As long as you haven't merged your branch into mainline, well, you simply do not know if your changes broke the application or not. It's only the minute that you are merging back that your CI process kicks in, and the longer your branch lives and the more branches you have in parallel, well, the more you delay feedback. So if your branch lives for a couple of hours, you are delaying feedback for a couple of hours. If your branch lives for a couple of days, you are delaying feedback for a couple of days. So remember, continuous integration is this practice that ensures always working software on mainline and that gives you feedback within minutes. Now, many teams like to redefine continuous integration by saying, well, you know, we have our Jenkins, or well, nowadays we should say GitLab, running against all of our branches. Now, having an automated build running against all of your branches is actually a good thing. It's a really, really good thing, but it's not continuous integration. You aren't integrating. The only feedback you get is whether the code that exists inside your isolated branch still compiles and whether you haven't introduced any regressions against the tests that exist inside this branch. You do not know how this code integrates with all the code that exists on all the other branches. So from this moment on, CI stands for continuous isolation. You aren't integrating external changes, and the rest of your team simply do not know how your work affects their work. If you are developing multiple features at the same time, in parallel, each on their branch, integrating these features together becomes exponentially harder with the number of features being developed in parallel and the number of changes required to implement that feature. Now, one way to reduce this integration problem is to adopt something that Martin Fowler calls promiscuous integration. Now, be aware, Martin doesn't advise promiscuous integration. He just named the pattern. So if you want to use a change that exists on another branch, you could cherry-pick that change into your branch. And so you are effectively communicating changes between branches. Now, the biggest concern Martin has against promiscuous integration is, well, apart from the fact that you introduce lots of process complexities, that you lose track on who has what on which branch. And so compare this complexity with the simplicity of having everyone in the team committing regularly into mainline and communicating their changes immediately with the rest of the team, creating a shared understanding of the code base and a collective ownership. As long as you haven't merged back into mainline, well, the rest of the team simply do not know in which direction you are taking the code to implement the feature you are working on. Now, this is okay if everyone in the team is working on different areas of the code base. But the minute two people of the team work on the same code base area, they are each blind on how their work affects the other. If, on the other hand, you are committing frequently into mainline, you are communicating with the rest of the team the direction you take with the code in order to implement the feature you are working on. And so, for instance, you could introduce a conditional showing to the rest of the team, well, here starts this new feature, and have this conditional turned off by default. Now, you could argue that introducing this conditional adds complexity to your code base because you are adding branching logic. And yes, you are right, we do add complexity. On the other hand, not adding this conditional doesn't remove the conditional. It's still there, but it's not visible, and it's absolutely not obvious, because your conditional is now your version control branch. And from this moment on, all your changes are invisible for the rest of the team. So remember, A version control system is not only there to version your source code, it's also a communication tool to communicate changes with the rest of your team. Because you are hiding work for the rest of your team, it makes refactoring very painful. So as long as you are just adding new code to your code base, integrating these changes is fairly easy. But the minute you start refactoring, you are introducing new concepts, new abstractions, and version control systems are very bad at versioning semantic changes. So if you have two people working each on their branch in parallel, one person performs a significant refactoring and merges back early, and a second person has a significant amount of changes on his branch, merging back to mainline will be fairly difficult for him. Now, the longer the branch lives, the more refactoring you perform, while the harder it becomes to integrate that branch with mainline, again, due to merge conflicts and potential rework, which makes the whole integration very time-consuming, which will slow down your team. And it is this slowdown of your team that works against the adoption of refactoring. And if we don't adopt refactoring, we all know that we aren't paying back technical debt. And if we aren't paying back technical debt, well, adding new functionality to the code base becomes much, much harder and much more time-consuming. And again, your team is slowing down. And so you end up in this vicious circle where your team slows down over time and eventually comes to a halt, and nobody really understanding why and how. When using feature branches, we are actually introducing batch work. So the longer the branch lives, the more changes are accumulated on the branch, while the bigger the batch size becomes. The batch size being the number of commits that exists since the creation of the branch. Now, all this work is just work in progress. All those commits is just work in progress. And work in progress is nothing else than inventory. And inventory is money that is stuck into the system. It's stuck into the system because your organization invested quite a lot of money to create all these changes that exist on all of these branches. But it doesn't generate any revenue for your organization unless all this code gets integrated into mainline and gets deployed into production so that you see how this code behaves in production, that you get actual feedback on this, and that you can take new decisions on it and start to run new experiments. So in order to reduce this inventory, we know from lean manufacturing that we have to reduce our work in progress, meaning we have to reduce our batch size, meaning we need to commit more frequently into mainline, integrating more often, getting close to continuous integration, and getting close to a single piece flow. And we know from lean manufacturing that single piece flow has a positive impact on quality and on throughput and reduces lead time and reduces time to market. Because we are introducing batch work, well, we are also introducing bigger change sets, and so we are introducing bigger risks. So if you are committing frequently into mainline, your CI process only has to process a small change set. So if your build happens to break, well, finding the root cause will be fairly easy because the change set is so small, and also because probably you introduced the failing change a couple of minutes ago, so you have enough context to fix that build. On the other hand, if you are using feature branches, the minute you are merging back into mainline, your CI process has to process a bigger change set. So if the build happens to break, finding the root cause will be far more difficult because the change set is so big. And maybe also because you introduced a failing change a couple of hours ago, or worse, a couple of days ago. So you don't have enough context anymore to easily fix that build. And so you run the risk of having a broken build for a long period of time. And so you just lost the monitoring of the health of your application, disabling you to perform on-demand production releases, which will have a negative impact on your lead time and your time to market. And lastly, it introduces lots of cognitive overload for your team members. So to start the development of a feature, you need to create a feature branch. To reduce merge complexity, you need to rebase frequently. To communicate changes between branches, you need to cherry pick. And when you are finished, you may not forget to delete a branch. So To develop features, your team members need to perform lots of operations on a day-to-day basis, and so they need to remember lots of version control commands, which creates cognitive overload and which could slow down your team. Compare this with the simplicity of having everyone in the team committing regularly into mainline, reducing redundant work, and getting to a very simple workflow. You pull the latest changes, you add your local changes, you commit, and you push, and you're done. It's fairly easy, it's fairly simple. Now, how can we avoid all of this? Well, by adopting continuous integration as it was meant when introduced by the extreme programming community in the late 90s, almost 20 years ago. Ensuring always working software on mainline, giving you feedback within minutes, enabling you to perform on-demand production releases at any given moment in time. This is the most important practice to adopt to enable the fast flow of work through your value stream and to get close to a single piece flow. And it requires trunk-based development. Trunk-based development is really what team members or pairs do in order to achieve collectively as a team continuous integration. It's a branching strategy where everyone in the team commits at least once a day into mainline. Change sets are fairly small and merge conflicts are very unlikely. Testing happens on mainline and releasing happens ideally from mainline. If you need some stabilization, you could opt for a short-lived release branch where fixes are done on trunk and cherry-picked into the release branch. Now, trunk-based development is really not a recent new hype, as I sometimes read on Twitter. It's there since a very, very long time, since the early 80s, when RCS was introduced as one of the first version control systems. It had support for branches, but everyone was cautious and stuck to trunk. Now, how do you achieve continuous integration? How do you make sure it doesn't become a mess when everyone in the team commits frequently into mainline? Well, we have several practices at our disposal, and I want to introduce 4 of them. And the first one is, in my humble opinion, the most important one, but from what I see, it seems also the hardest one to adopt. It's working in small incremental steps, breaking up large changes in a series of small incremental changes. Steve Freeman and Ed Price make this analogy with surgery in their book, Growing Object-Oriented Software Guided by Tests, where they say a surgeon prefers a keyhole surgery instead of opening the patient body, because it's less invasive and therefore it is cheaper. Well, for the same reasons, we prefer to work in small incremental steps, because it's less invasive. We aren't ripping apart the application, and we keep the application always working. And therefore it is cheaper because we can perform on-demand production releases at any given moment in time. But this means several things, and the first thing it means that you only commit on green. And this is where test-driven development supports continuous integration. You start by writing a small failing test. You add just enough production code to get the test passing. Once the test is passing, you commit and you push. And then you start your refactoring. If the test is still passing, you commit and you push. So test-driven development creates this commit cadence to achieve continuous integration. Second, you absolutely need a decoupled code base in order to be able to work in small incremental steps. If your code base is too coupled, any change will rip apart your application. It will just ripple over your whole code base, making sure your application is not working for a long period of time. And this is why adopting hexagonal architecture, ports and adapters, and some of the solid principles is so important. So they not only improve your code base quality, but it will also have a positive impact on your time to market. And lastly, you absolutely need lots and lots and lots of very, very, very fast tests. You need lots of tests to gain enough confidence that you aren't introducing any regressions when you are committing frequently into mainline, and they need to be very, very fast to enable you to commit frequently into mainline, because you have to run them every time you want to commit. So when tests are too slow, two things happened. Either teams don't run them, and so you run the risks of introducing regressions, or they tend to run them less frequently, and so they start to batch up work, and so they are increasing their feedback cycle, which will have a negative impact on the quality and will have a negative impact on your lead time and your time to market. The second practice is the most easy one to adopt. If you have unfinished functionality, just hide it. You don't need fancy feature toggling for that. It's perfectly acceptable to have unfinished functionality sitting in production, even behind a publicly accessible URL, as long as it is not discoverable. So if you are adding, for instance, a new screen to your user interface, well, don't add a menu item to access this screen in your user interface. Only add this menu item when the screen is finished and ready to be released to your users. You can do the same when adding new REST endpoints. Just don't document them, or just make sure they are not discoverable. It's fairly easy. If you have to perform large-scale refactoring, let's say you want to replace an algorithm by another algorithm, or you want to replace some library like your logging library or your object relational mapping library or your user interface framework that you are using. Instead of using branch by version control, well, adopt branch by abstraction. So branch by abstraction is a practice that allows you to perform large-scale refactoring and still be able to add new functionality while doing this refactoring, still being able to release new functionality while doing this refactoring. So how does it work? You start from a situation where various parts of your code base are calling some supplier code. This library you want to replace, this algorithm that you want to replace. So first thing you do is actually introduce an abstraction layer. So in most languages, this will be an interface. In some languages, this will be an abstract class, or you can use a delegate class. Then you start by changing your client code to call this abstraction layer instead of calling the supplier code immediately. And at the same time, you also provide a second implementation for your abstraction layer, using this new library you want to introduce or this new algorithm that you want to use. And lastly, you gradually swap out the old supplier code and replace it by the new supplier code. So branch by abstraction is one of several implementations of parallel changes pattern, which is also known as expand contract. Now, I have to say that it adds quite some complexity to your code base and that you will have to think harder and that you will move slower. But it has the huge advantage of never blocking the flow of work through your value stream. You are never blocking the delivery of new functionality while you are performing this large-scale refactoring. It's very powerful. And it has obviously a positive impact on your time to market and on your lead time. And lastly, we have feature toggles to decouple code deployment from feature release. So what happens is that your new code, your new feature gets into production like days or weeks in advance, but it only gets released, well, days or weeks later to the users. So during this period, this new feature is hidden for the user and allows you to test that feature in production, somehow removing the need for an expensive staging environment that should resemble your production, but never really does. In addition, you can also, well, simulate production load to have user sessions perform invisible calls to this new functionality. Once you think you are ready, well, you can gradually start releasing to your user base and see how it behaves when being used by real users. If it behaves well, you increase the number of users using this, and this is called canary releasing. If it behaves bad, well, you can just roll back by just turning off the feature, which is far less risky than having to redeploy a new version of your application into production. Now, to be fair, when done badly, feature toggles can be very evil too. It can go horribly wrong when done badly. The biggest example of this is what happened to the Knight Capital Group, which was one of the biggest trading firms that traded in US equities on the NASDAQ and the New York Stock Exchange, and they managed to lose $460 million in 45 minutes. Ouch. Because of a bad feature toggle implementation combined with manual deployments where they forgot to deploy on 1 of 8 servers. And the end result is the company went bankrupt. How feature toggles can go awfully wrong. Yeah, right. So to avoid this, you need to manage your feature toggles. And so like with work in progress, well, we like to limit our number of active toggles. So whenever a toggle is not needed anymore, just remove it immediately from your code base. Otherwise, you run the risk that you have a code base with lots of toggles, no one knowing wherefore they are used, no one daring to remove them. I've heard those stories. Second, make sure your toggles are independent from each other. Don't have a situation that to turn on a feature, you need to turn on toggle X, toggle Y, toggle Z. It's very difficult to reason about this, and it makes testing very difficult. When we say toggles, we say branching logic. Branching logic needs to be tested, so all your automated tests need to run against your application with the toggle on and off. On the other side, manual exploratory testing only have to happen against the next situation that will happen in production. So if the toggle will be on in production, you do your manual exploratory testing with the toggle on. And lastly, well, branching logic means, well, complexity in your code base, maintainability. There are different ways to implement this. Steve Hodgson wrote a very good article about that, on how to implement them right. It's called Feature Toggles. It's published on Martin Fowler's Bliki. It's quite a long article, but really good. Now, whenever I suggest string-based development, I always get this same question asked. Every time. What about code reviews? How do you do code reviews when you don't have branches anymore? Well, first of all, although code reviews is a common practice in our IT industry, it's still optional. It's not a mandatory practice. If your team is very mature, you can choose to not do any code reviews. You could assume they will do the right thing instead of thinking they are stupid and that you need a process to fix for that. And this has been confirmed by the book Accelerate, where they found out that both teams doing peer code reviews and teams doing no peer code reviews achieved higher IT delivery performance. If you still want code reviews, well, a fairly easy way to achieve that is with pair programming or mob programming. It gives you continuous code review for free, pre-commit, before the code gets into mainline, because several pairs of eyes are looking at the code while it is being written. In many XP shops, this is good enough as a code review. Dave Farley also reported that even in highly regulated environments like high-frequency trading platforms, it is good enough as a code review. Now, if you don't do pair programming or you do pair programming and you still need a formal code review, well, you still have 2 post-commit review options. And the first one, well, is the most known one, is pull request, but this time with short-lived branches, like a couple of hours. However, there is a risk that this short-lived branch lives longer than expected. You know, the ping-pong that happens between the reviewer, the reviewee. Reviewer is not available, then the reviewee is not available. Or worse, you decided to do this slightly small refactoring, and that takes you a little bit more time, and off, you're gone for a day or 2 refactoring. The downside of pull request is also that it blocks the flow of work. It blocks the delivery of your feature. As long as it didn't went through this gating process, that feature doesn't get into production. Therefore, while I had quite good experience with the last option, if you still want to have code reviews, is reviewing on mainline. Now, you could argue that bad quality code could get into production, and yes, you are right, and that will happen for sure. Now, In my humble opinion, it isn't a problem because, well, bad quality is not a bug. Code reviews aren't there to catch bugs. For that, we have our automated tests and our manual exploratory testing. And second, well, if you decided to do code reviews, every commit will be reviewed at some point in time. And so at some point in time, this bad quality will get removed out of production. But it requires team commitment that whenever an issue is found during code reviews, it gets handled immediately so that you get this bad quality quite fast out of production. Now, what are the benefits of trunk-based development? Well, if you are committing frequently into mainline, you are creating more frequent builds. And if you are creating more frequent builds, you can deploy more frequently into production, enabling the fast flow of work through your value stream, getting you close to a single piece flow, which will reduce your lead time and your time to market. Now, because you can deploy more frequently into production, you can run more experiments. And so you will be able to find more unmet needs of your customers and find more ways to delight your customers, which is a huge competitive advantage. Because you have more frequent builds, you will uncover more problems earlier, allowing you to fix them while they are still small and easy to fix. And so allowing you to build quality into your product instead of testing in it later in the product. And so this will lead to better stability and higher quality. So trunk-based development predicts better quality, higher stability, and higher throughput. And this has been confirmed by both the peer-reviewed academic paper, The Role of Continuous Delivery in IT and Organizational Performance, by Nicole Forsgren and Jaz Humble, and by the book Accelerate from the same authors, together with Jean Kim, that trunk-based development, together with continuous integration, are a significant predictor of the adoption of continuous delivery, which in turn will predict higher IT delivery performance, and together with the adoption of lean management and a generative organizational culture will lead to higher organizational performance. But where's the evilness? Tell me. You're speaking for 42 minutes and you never mentioned the evilness. Well, and this was an epiphany to me, the evilness is not so much the problems that are created by using feature branches. The evilness really hides behind the use of feature branches. Meaning, what are the real reasons teams are using them for, which is not necessarily the reasons that proponents of feature branching told me in the beginning of this presentation. In my humble opinion, the real reasons are there is a lack of incremental software engineering skills in the team, or the code base is just too coupled, preventing the team to work in small incremental steps. Or there is a lack of automated tests, and so you don't have enough coverage, and so the team doesn't have enough confidence to commit more frequently into mainline. Or the build is just too slow, preventing team members to commit frequently because they have to run this build each time before committing into mainline. So if your build is taking 45 minutes, you can only commit every 45 minutes. And so you are starting to batch up work. So, and in my opinion, feature branching is hiding all of those problems, where if you would adopt trunk-based development, it would just uncover all of these problems. Now, to be fair, many teams, many organizations have bigger problems than feature branching, and many times they need to fix other things before getting to that. Now, does it mean that trunk-based development is easy? No, it isn't. It's quite hard to adopt. And like with test-driven development, over time, we tend to forget how difficult it was to start with it. And also, well, it requires a big mindset shift. And from my experience, it requires a huge amount of effort to get teams to just run an experiment. But once they run an experiment and they see the benefits of string-based development and they see how much easier the workflow is, while they cannot imagine another world again using branches. Thank you for your time.
And we have a lot of questions. Actually, it would probably take as much time to answer all of them. Okay, where do we start? So there were questions again about the code reviews.
Check.
Check, yes. Okay, there's one with a lot of discussions behind it. Using feature toggles requires extra developer efforts, and moreover, developers has to review existing toggles constantly and clean them. Maybe can you comment some of it?
Yeah, exactly. So Pete Hodgson wrote several articles about feature toggles. So he worked for ThoughtWorks, and then afterwards he worked for Split.io. And on the blog of Split.io, he wrote several blog posts, and one of them is on managing toggles. So one of the things teams do is whenever they add a new toggle, they add a ticket on a board, and they set up a whip limit. And if they arrive at that whip limit, well, whenever they want to add a new toggle, another one has to be removed from the code base. It's one option. The other option I've heard of is, well, whenever we add a toggle, we add a ticket to the backlog to remove that toggle, to make sure we don't forget to remove it. Now, if you use online tools like Split.io or Dark Launch, I think it's called, yeah, they have dashboards that gives you an overview of all the toggles that are active. But yeah, right, it gives additional management. On the other hand, it gives you quite a lot of flexibility. It allows, it enables operability. Does that answer the question?
Yeah, I see some people nodding, so it's a good sign. Let's take another one. We are merging master before building feature branch, so our masters are always tested as they are merged back into master branch. What are disadvantages of this approach, if any?
Right. Let me repeat that. So we are rebasing master into the feature branch. Is it that? And so therefore we are reducing the problem. Yeah. As long as you have one branch that is active. The minute you have multiple branches in parallel, well, you don't have the integration with the other branches. It's just that. You simply don't know how your branch is going to integrate with that other branch that is living.
Okay, and maybe let's take the last one. So there was a question about this unfinished screens, for example. Why just hide them, not considered a security vulnerability?
Yeah, exactly. And that's why you have a deployment pipeline that will check if you have security tests, that will make sure that unfinished features are actually checked for security vulnerabilities. Whew, difficult word. But yeah, so that's the purpose of having a deployment pipeline, is to make sure that it's actually, how does it, oh, it's turning off, well, whatever. So it's to make sure that all the tests are being run. All right. Yeah, so my slides has, I have 3 additional slides with just resources on string-based development, all the everything I used to create this presentation. All right.
Then thank you, Thierry. May I ask, can you just go also to the Slack and try to answer some of the remaining questions?
Yeah, I'll do that after lunch. Sure.
Sure. And thank you, guys.
Thank you.